Unit 3.1 is on functions. Right, what is a function? It is a situation when one value depends on another. So if you phone the plumber and because your pipe is leaking, and he says, right, I will come out, but I charge 150 rands to come out, and then I charge 200 rand per hour labor, then what you're going to have to pay him depends on how long he was working on your pipe. So the cost depends on the time. So obviously in life, all the time you have one thing depending on another. Let's just look at a very simple. If I say y equals x plus 2, then the value of y depends on the value of x. So y is the dependent variable, but x is the independent variable. We also say x is the input. It's the value you would choose. Independently of what y is, you will choose the value, put it in, and then you're going to get an answer for y, and that will be your output. Okay, and the big thing that makes it specifically a function is that you will get only one solution for each x. So each x value that you chose to put in there will only give you one possible y value. That makes it a function. Right, notation. How do we write a function? Well, one is the thing that we've just done by saying y equals x plus 2. But we can also say f of x, listen to me, f of x equals x plus 2. This then says whatever I put in the brackets there in future, that's my input, right? I must put in that position. And once I've worked out the answer, then the whole fx is the output. So if I say work out f of 2, then you put a 2 in the place of x. If I say work out f of negative 2, you would put a negative 2 in the place of x. And the 4 and the 0 are then your output. Right, we like to write the solutions as an input and output value. So in the first case, we put in a 2 and we got out a 4. So it's always first the input, which generally when we're working with x's and y's is the x, and then the output, which is the answer you got, which is generally your y. But of course it can be any letters, it doesn't have to be x's and y's. For instance, I could give you this function. V of r is 4 over 3 pi r to the 3. This is the volume of a sphere. Right, and you know what a sphere is? A round thing like a ball. Right, the output will be the volume. The input will be the radius. So the volume depends on how big the radius is. Remember that pi is not a variable. Pi is a constant. So the only variable there is the r. And the name here says volume depends on radius. Right, let's do some examples. I'm going to give you two functions, and instead of calling them y's, I'm going to give them names. So the one is fx and the other one is gx. So these are the definitions of my functions. From now on, it depends on whether I talk about f of g, which one of those two I'm going to use. So if I say, find f of 4, then I go to the rule for f and I put a 4 where the x is, and I work that answer out. If I say find g of -6, I go to the rule for g and I put a -6 where the x is, and my output is -1. I can ask it a different way as well. I can say if f of x equals 243, what is x? So now you must read it carefully. I don't put 243 in the place of x. X is what I'm looking for. I put 243 in the place of the whole fx. And I try and find x. So what will I do here? I will do 3 to the 2 is 9, 3 to the 3 is 27, 3 to the 4 is 81, and then I will find 3 to the 5 is 243. So that means x was 5. So if they give you fx, they're actually giving you the output, and they're asking what is the input. Let's do one more like that with g. I'm going to tell you gx is 24, and I'm going to say, well, what is x? So that means 6 over x. The x is the one I don't know, but I know that equals 24. Remember what we said, if the x is underneath, we have to take it across, and you've got to do the opposite, which is times. So you're going to get 6 equals 24x. Then you can get rid of the 24 because you want the x alone. And if you simplify this on the left, you get x equals 1/4.